Hello everyone, welcome to this video where we're going to be looking at one of the newer capabilities within SRAM 2023 using the multi-story building process. We're going to be looking at some of the new functionality within grids for this particular video. Now within this video series we're going to look at how we can construct multi-story buildings using this multi-story builder workflow, and it really all starts with grids. And so we're going to introduce that now. I have a blank model open at the moment. And if I go to the Edit Grids dialog, we can see here that we have a few different grids. Now normally we would have 1 meter, 5 meter, 1 foot, and 10 foot spacing grids by default. Here you can see that I've got the base grid, which would normally have acted as by default, my 1 meter spacing grid. However, I've zeroed out the grids already. And it's at this point that I wanted to introduce some new changes to this type of grid definition. We now have a few different grid types. We have base grids, which you can see on the screen, and their childs, which we'll refer to later on. And these are what I'll be referring to in this video as grid lines. As you'll be able to see as we move along, they have labels that can be modified. They can also be customized, so you can actually create your own custom grid lines. And they're really useful when adding objects in plan view using the multi-story builder. And they're always based off of the global coordinate system. We also have construction grids, which would represent these 3 grids below, the 5 meter, 1 foot, and 10 foot spacing grids, and any other grids that you might create that aren't underneath the base grid set. And these are more akin to the previous versions of SRAM's grids based off of the user coordinate system, so they can align with, for example, a vertical plane or whatnot. We've also added a few more toggles into the grid options dialog here, as you can see. One of them I think that's perhaps most important to this exercise is the extend grid scope toggle. So basically what happens is if this toggle is turned on, SRAM is going to look at all of the entire 2D plane of grid line intersections and member intersections and so on, even with other grids. So if you had multiple grids under a base grid, for example, you can look at where they might intersect one another, or if you have members that are crossing your grid lines, you can look at where those members intersect your grid lines. This gives you a lot more control over the scope of the grid and the objects that are contributing to the grid and the intersections for insertion points. So we're actually going to start creating some grids just as a demonstration here. And I'm going to work within this base grids folder set. So if I just right click here, I can say new grid set, and I'm going to create a child grid underneath this. I'll start off with a rectangular grid, so I'm just going to give it a name, call it rectangular. And then I'm going to open the grid by just left clicking here, and you can see that it's currently empty. And just like other versions of SRAM, we can define our grids in the X and Y direction. So here I'm going to go with one grid line at 0 increment spacing in the X direction, so that will be right in my origin. And I'm going to do another 10 at 1 meter spacing in the positive direction. And we can see what that's starting to look like here in this little preview. And in the Y direction, I'm going to do something similar. I'll have 1 at 0, but I'm going to have 10 at 1, and I'm going to do 10 at -1 as well. So we can see what this is starting to look like. We get a preview, and just like I had alluded to earlier, we do also get these grid labels. Again, these can be appended. We can customize our grid lines. Not really going to go into too much detail on that right now, but just wanted to mention that that is available. I also want to enter a grid increment, which will come in handy when we may want to manually adjust our grid graphically versus doing so within this dialog. So here I've got one grid. The rectangular grid, as we can see here, we've got basically 20 meters of width in the Y direction and 10 meters of width in the X direction. Now I'm going to go back to the base grids folder and I'm going to create a new child grid set. I'll call this one here cylindrical. And it's not currently open. The rectangular grid is currently open, so I'm just going to open this grid. As you can see, it's empty, so I don't have any data under it, which is to be expected. And rather than using the Cartesian grid type, I'm going to use the cylindrical grid type. So I'll just left click here. We have a change to the spacing allowances here. And in the X direction, I'm going to do something similar, just one at radius of 0 meters, so right at my origin. and then another one at a radius of 10 meters. And in the y direction, again, I'll go 1 at 0, and this time I'm going to go 4 at 45-degree angles for theta. We get a preview of what that looks like once again. And I can also modify the angle, the offset, and so on. So I actually want this to extend off of the edge of my rectangular grid. So I'm going to give it an angle of -90 degrees. You can see when I enter that data and I click into a different cell, we get a preview of what that looks like. And the x offset that I'm going to use is 10 meters. So it's just basically meant to extend off of the end of my rectangular grid. It gives me a little bit more flexibility over the geometry I'm creating with this grid set when we combine the two together. So click OK. And I'm going to keep everything as is. And right now it's gone to the last grid I created and selected. Now I'm going to switch to the grid that we created before this, the rectangular base grid. And again, note that for these grids that we created under the base grid's parent grid, we have this bracketed signal base just to indicate that it is a base grid. And I can see that grid here. Now I may want to look at the two superimposed next to one another, and I can do that by just left-clicking on the base grid option at the top. And now I can see these grids again right next to each other, and I can work on them kind of in harmony. So I'm able to define geometry on not just one grid but multiples. Again, because I have that extend grid scope turned on, anything within the plane of this grid will also be essentially allowing me to create insertion points for my model. A few other controls that we have. If I go to the Edit Grids dialog, I could continue creating a new grid, and I'll just call this one Grid Line. I'm going to select this grid, and here I'm just going to create a grid that extends in the x direction. I'll say 1 at 0, 1 at 10, and then in the y direction it's just going to have one grid line at 0. And with this, we'll be able to enter again also our rotation angle. So let's say 30-degree rotation. And I'm going to click OK. And we can see what this looks like. Just a single grid line, but I have insertion points at either end. And this is again part of my base grid folder. So if I look at this, I can see that now I have an angled base grid insertion point set here. So I could, if I were using the member definition tool, go in and define a start point for my member at the intersection of this angled member, or sorry, grid line, and wherever it meets another grid line. And to extend that even further, if I did have perhaps a need to create a grid line somewhere where it was a little bit harder for me to generate this grid myself, or just quicker to draw in a line, I can do that as well. So let's say I have a line right here, and I want to use it as an insertion point. Now right now this is a member, and that member could theoretically have stiffness and mass and contribute to the overall behavior of our model, but I can always delete it afterwards and just use its insertion point. So here I have an insertion point where it matches this grid line intersection here, and here, and here. So it can help me with my modeling aids if necessary. Now let me go back into the grid dialog, the grid definitions dialog, sorry. And we'll notice here if I just select, for example, my grid increments, my rectangular grid and look at the grid increments, we see we have an x and y grid increment of 0.1 meters each. So what does this mean? Basically it allows us to draw in, and I'll just work with the rectangular grid for now. It allows us to create our grids and then modify them graphically. We have this toggle that's available in the grids dialog as well. It says unlocked or locked grids. And we also have the option to lock joints that are on these grid lines to the grid lines, so that if we were to modify these grid lines, all the joints in the geometry will be able to move with those grid lines. It's great for mass editing of geometry, which we may need to do from time to time. And I don't have any geometry in this model that I need to edit, but here what I want to show is just how that would work. So I'm just going to unlock these grid lines. And all I need to do is just left click on one of the grid lines. And if I left click and drag, we get this grid coordinate that appears and basically shows me wherever this grid line is being moved to. So originally it was a nice even 1 meter spacing. Now I'm moving it a little further, 4.4 meters. I can always click the undo button to move it back. And when I'm doing that, it's basically moving a plane of objects. So if I had, for example, a column or a set of columns here and beams, it would move that one single plane of objects however far I've moved this grid line. Another option is we can hold down the Shift button on our keyboard and left click on a grid line. And rather than moving a plane, we can move a volume of objects. So rather than just, for example, one set of columns and beams that are on that grid line, we could move everything that's on the opposite side of this grid line from where the direction I'm moving it. So here I could say that I'm moving that one grid line, but everything past that grid line is moving along for the ride as well. So it allows for some useful editing tools there. And another useful feature is we can use this display dimension information to view the geometry of each grid line spacing. So this can be helpful when laying out our geometry, but also when adjusting it graphically like that. And we can see this not only for individual grids, but for the base grid set as well. So we can see that for the rotation of our grid lines and so on. So it can be very useful in this application. Now I'm actually going to switch gears and go to another blank model that we're going to start using to lay out geometry that will eventually be used to generate a 3D building structure using the Multistory Builder workflow. Now in this particular tower that we're going to create, we have a few different components involved that will require multiple grids. So we have a core wall that's going to extend through the height of the tower. We're also going to have the tower. And then next to the tower, on the first few floors, we're going to have a podium. So we want to set up grids to aid with that type of geometry creation. So in this example, once again, I'm going to go to the Edit Grids dialog. And I have already zeroed out the base grids folder because we don't need that for this particular application. And I'm just going to create some grids. So what I'll do to start is just right click on the base grids folder, create a new grid set, and I'm going to call this one core. And this will be essentially the template for how I'm going to sketch out my core wall. So left click, open this grid set, and I'm going to define effectively the dimensions of my future core wall using these grid spacings. So I have one grid line at x equals 0, another one at x equals 3.5, another one at x equals 3, which will represent the length of the link beam connecting these walls. And finally, another one at x equals 3.5 to represent the other flange of our core wall. And in the y direction, it's going to be a little simpler. We're going to have one at y equals 0 and one at y equals 8 meters. And I do want to enter grid increment. So I'll say 0.1 meters in x and y directions. And finally, we'll just go with a red color to help us distinguish this from other grids in our model. So here I've entered this data. I'm happy with it now, and I'm going to left click on the base grids folder once again and right click to create a new grid set. And for this grid set, I'm going to call this one my tower grid set. So here I'll just name it tower. And we're going to use 5 meter spacing because we're going to have a reinforced concrete tower. It's going to have a reinforced concrete slab and reinforced concrete columns. And we're going to use x equals, or a grid line at x equals 0. And then we're going to have another 8 grid lines at 5 meter spacing. On the y side, we'll have one at 0 and 6 grid lines at 5 meter spacing. And of course, we're going to continue with our grid increments just to allow for the graphical adjustability. And I'm going to give it a color, which will be a blue color here. And we're ready to go for this tower grid as well. And finally, one last grid line. What we're going to do now is just select the base grids folder. We're going to right click on the new grid set, and I'm going to call this one podium. And for my podium grid, I'm just going to open this grid set, and here I'm going to go with a number of grids in the X direction. I'll have 1 at 0 and then 4 at 10. On the Y side, I'll do 1 at 0 and again 4 at 10 as well. And this is going to be comprised of, our podium is going to be comprised of a composite steel structure that's going to be adjacent to our reinforced concrete tower. And for this reason here, we're actually going to offset this grid. We're going to offset it in the Y direction. It's going to go off the end of our grid. And we're going to give it an offset of 30 meters in the Y direction. And the grid increment that we're going to use is 0.1 meters in X and Y. So effectively this will be right off the end of our tower. We do have room to adjust it. So if we want to represent, for example, a seismic joint or something where there is a bit of a gap, that's very easy to do with this offset. And I'll keep this color as black for now. So I'll just left click, click OK. And now I'm looking at the podium base grid, which is helpful. I can zoom out and I can see where this lines up with my global coordinate system. Again, all these base grids are based off of our global coordinate system. I can look at my core grid, and I can look at my tower grid as well. And they're all basically right, kind of created off the corner of this grid, user coordinate system rather. And now if I look at my base grids folder where they're all right next to each other, it becomes pretty apparent to me that I don't really want my core grid to be at the corner of my tower. So I can reposition that as well. What I can do is I can go back into this Edit Grids dialog, and I can go to the core grid, and I can say, you know what, this isn't working for me, this current position. I want it to be kind of centered on my structure. So I'm going to give it an offset in the X direction of 15 meters, basically half the distance along the length of my tower. And in the Y direction, I'll give it an offset of 11 meters. And then I just click OK. And it may not be as obvious when we're just looking at this grid in isolation, but when we look at the base grids folder, we can now see that it is better aligned with the rest of the structure in terms of where we wanted it to be. And we could do the same thing with the podium grid again, as I mentioned, offsetting it a little bit if we wanted a seismic joint between the tower and the podium. And just like all the other grids that we created in the previous exercise, we can also view dimension information and see that presented to us right up in front. So in the next video, we're going to look at how we can actually use the Multistory Builder workflow to generate geometry from a plan and essentially create vertical stacks of stories based off of that information.